Hello. Hope my voice is audible to you. Thank you for coming live. So, very good evening, everyone. A warm welcome to all of you for coming live to this webinar. So, today I'm going to talk about diabetics prediction using Python. So, this is a machine learning project and we are using Python programming language for deploying this project. For completing, for entire project we are using only Python programming language, so we don't use any other programming language in this project. So this is completely based on Python programming language, and today we are going to develop this project right away from scratch, from dataset to deployment. So that is the main agenda of this webinar. So we are going to create a project called Diabetics Prediction System using Python programming language. So this is a web application which I'm deploying it on a cloud platform, so that the customers of this project can able to interact with the web application, and that web application will give you the result for customer also. So this is completely from scratch. So I'm using only Python programming language for for building this project. So this project is based on machine learning. So let us get started without any delay. So before we start, let me introduce myself. My name is Maddy, alias Madhu Parvatneni. I'm a solution architect at Madblocks Technologies. I was an IoT, machine learning and blockchain domain expert. So I used to work on these kind of cutting edge technologies. So in this webinar, purely I will be talking about how to deploy a machine learning project on cloud platform. I will take an example called Diabetics Prediction System, and you can connect with me on LinkedIn. So this is my URL. You can scan this QR code. It will take you to my LinkedIn profile. You can stay connected with me on LinkedIn as well. So please stay connected with me on LinkedIn. If you have any question or if you want to develop any kind of machine learning project, you can send a message. If you need my help, obviously I will be there for you in completing your machine learning project. So you can send me your project details, or you can send your question or query in the LinkedIn. So I can able to interact with you. I can able to have a small chit chat with you and help you out in building your machine learning project. So before we start, hit like the video, subscribe for this YouTube channel. We have a specific goal for February. So we wanted to have 100 subscribers subscribing for this YouTube channel. So we are doing various kinds of lives on different cutting edge technologies, not only machine learning. Last time we have did for IoT. Today we are doing it for machine learning, and tomorrow we are doing it for blockchain. So we have a specific webinars coming up for all of you, so that you can gain some knowledge and you can start developing your projects. So main agenda of this webinars is all about building projects, learning some knowledge and putting it into the innovation. Okay, so because innovation is always very important and we always have to be innovate always. So if you want to create some kind of innovations, you have to understand what kind of technology is there, how to use the technology in the innovation and all that. So for that reason only we are doing this kind of webinars, so that this kind of webinars will help you out really, right? So if you have not joined in our Telegram group, so we have created a Telegram group for question and answers. Later, if you are not joining live, later if you watch this video, if you want to do this project, you can also develop this project, because I'll be sharing all each and everything in detail. I'll be sharing the program code, I'll be sharing the architecture that is used in this project, I'll be sharing each and every minute detail related to this project. Later also you can watch this video and frame by frame, and you can develop this project. Later if you're developing this project, if you have any question, if you get stuck in between, or if you get any error, if you are unable to debug that error, you can send a message in the Telegram group. We have a domain experts who have joined in the Telegram group. They will be replying you. If I'm free enough, I will also reply in the to your messages, to your errors, that what you get while developing this project. And also we are organizing various kinds of webcast and related to various cloud platforms as well, because this Sunday I'm coming up with Maddy's Azure talk, so which is a one kind of initiative from me, where I'll be talking about Azure cloud services every Sunday at 6 o'clock in the evening. So if you want to get the latest live updates from my side, you can join in this Telegram group and you can stay connected. Okay, and if you don't want to miss this kind of events, you please subscribe to our YouTube channel and hit the bell icon. Okay, so let me jump into the webinar. So this webinar is all about building a project called Diabetics Prediction System using Python. So this is a project which is based on machine learning. So the main objective of this project is to diagnostically predict whether or not a patient has diabetes or not, based on the certain diagnostic measurements included in the data set. So this is a data set which I have taken from from National Institute of Diabetes and Digestive and Kidney Diseases. So this is a standard data set which I've taken to diagnostic all the parameters which is taken in the data set. I will also show you the data set. I will also I will also explain you each and every attribute which is there in the data set, and so that you can easily understand what data set is, how to use this data set and what kind of machine learning algorithm I will be using it. So so this is the main agenda of this webinar. So our webinar agenda is to diagnostically predict whether the patient has diabetes or not based on the diagnostic measurements. Okay, so let us look at what kind of diagnostic measurements are there in the data set and also the remaining details in the coming slides. And if you want a certificate of participation for this webinar, you can also look at the video description. You will have a link, and if you register there, you will get a certificate of participation of this webinar. If you want to become a project subscriber, we will be also giving you a certain kit and certificate, so that you can put this project as your academic project as well. Okay, so let me jump into the next slide to show you what is the block diagram which I'm going to use. So this is the main architecture of this project. So this is the main block diagram of this project. So here let me tell you two important things. So in this architecture there are two important stages. Okay, so let me use marker to identify them. Okay, so this is one. So this is one, and the second one is the remaining thing. Okay, so here we have a diagnostic. So we have a admin, or you can say an attender or a nurse even. So he wants to diagnose the patient record. Okay, so what he will do is he will send a request. Okay, he will send a request to the Heroku cloud platform. So this is a cloud platform. So this cloud platform, on this cloud platform, what we are doing is we are deploying a machine learning application. Okay, so in this webinar I will show you how to create that machine learning application, how to deploy that application on Heroku platform. So I'll be using Heroku platform. So the patient, the attender or user who is using this application will send a request to the Heroku platform, and on the Heroku platform there will be a machine learning model which is already deployed. So that data will be passed. So that data will be passed to machine learning model. So whatever the data, whatever the diagnostic measurements are there, so all that data will be passed to the machine learning model, and the machine learning model is going to predict whether the patient has diabetes or not, and that result data will be passed to Heroku platform, and the Heroku platform, from Heroku platform it will be passed to the user. So user will be understanding whether the patient has diabetes or not. So user is not a patient, user is admin, or you can say a compounder, or you can say attender, or you can say nurse or a technician who is generating a diabetes report based on the diagnostic measurements. Okay, so that person is sending all this records, all the test details to the Heroku platform, and the Heroku platform is passing all that data to the machine learning model, and the machine learning model is diagnosing all the is predicting the data based on the user input, and that data which is a predictable outcome, that is being passed to Heroku platform. From Heroku platform it is being passed to user back. Okay, But before that, this is like, this is like a usage, right? So this is like a front end. Okay, this is like a usage, but in the back end you will have, what we have to do, we have to create this machine learning model. So we have to create a machine learning model. To create a machine learning model, what you need a data set. You need a data set. So using that data set, what we are doing, we are passing this data set to the machine learning algorithms, and that machine learning algorithm is going to learn from this data, and it is creating a machine learning model. So here we have a machine learning algorithm. So there are different types of machine learning algorithms. In this video, I'm not particularly talking about any kind of machine learning algorithms, but I'll be using a machine learning algorithm called Knm Classification. So here what I'll do is I'll simply pass this data set to the Knm Classification, and Knm Classification, what it will do, it will create a learning model. So that learning model will be deployed. So that learning model will be deployed on Heroku Platform, so that the user, whenever user wants to predict some data, so he can pass the data to that machine learning model. So there are two important phases here, right, as I said. So one is like usage, second one is training the machine learning model. So what we need a data set. So without any, because machine learning is all about learning from the previous data. So we have to pass some previous data. From that previous data, the machine learning model will understand some mathematical correlation between the inputs and outputs. From that, it will start learning, and once it starts learning, the machine learning model can able to predict the future outcomes, right? So all this we will be doing it step by step from scratch, so that you can able to understand. So in this video, I'm not going to talk about what is machine learning, types of machine learning, algorithms of machine learning, but here I'll be showing you how to implement a machine learning project. Okay, so later in the upcoming videos, I can explain you each and every detail related to machine learning, but as of now, I'm just focusing on the applications of machine learning. What how to deploy this, how to create this, how to use machine learning here. So all that I'll be discussing about in this particular video. So there are some prerequisites here. So as I said, because this project is based on machine learning, so the person who is building this project should have a basic knowledge on machine learning. Okay, which machine learning he has to use, which algorithm he has to use, which kind of machine learning he has to use. So user should have, developer should have a basic knowledge on machine learning to build this project. And also, along with machine learning, people should aware of you should aware of Python programming language as well, because Python is a fundamental programming language which I'm using today in order to create this project. And also I'll be using Heroku account, because Heroku is a cloud platform where we can easily deploy the machine learning model. Today I'll show you how to deploy this particular project on Heroku platform. So you should able to create an account. Okay, creating an account in Heroku platform is simple and it is free. You can use a simple, you can give some details like full name, first name, last name, and email ID and mobile number, and country called India, and you have to choose a platform called Python there, because they'll be asking you which programming language you wanted to use on Heroku account. Then if you specify Python, then immediately account will be created. They'll be sending a verification link to your email ID, and you can verify your account, so that your account will be active. So you should have Heroku account, and I'll be using a platform called VS Code. So in order to code the entire project, I'll be using VS Code, Visual Studio Code. So you can use any other platform also, like PyCharm, or you can use Sublime Editor, or you can use a simple notepad editor. So anything is fine. I'm using Visual Studio Code. Obviously you need Python interpreter installed on your laptop. Okay, because without installing Python interpreter, you cannot able to you cannot able to run your application, right? So Python interpreter is very important. And also along with this, you need Git. So the Git software also, this is very important, because if you want to deploy your machine learning model, say you're developing a machine learning model related to diabetics prediction system, if you want to deploy this, you need obviously a Git platform. So you have to install this Git. So you can search in Google, you'll get it easily. Okay, git-scm.com. So that is a website. You can download Git for Windows, and you can start installing it. And if you have Git, then obviously you can able to complete this project easily. Okay, so Git is used for deployment. Python interpreter is to run the application. VS Code is an editor where we are using now, and Heroku account to deploy the machine learning platform. We need Heroku account, and obviously you should have a basic knowledge on machine learning. You have to understand, what kind of machine learning applications are there, or what types of machine learnings are there, because you need to choose according to the data set which is provided. So all that, I'll take a basic overview on this kind of things, okay, as we go ahead in upcoming slides. Okay, let me go for next slide. So here, as we preferred Python as a development language now. So Python is very popular because it is interpreted, it is interactive, and it is a scripting language, and it is a old programming language. So when it is old programming language, you'll have broad library support. So libraries are available for Python. So for particularly on machine learning or artificial intelligence applications, people use Python language because it has a broad library support. Okay, so there are 4 libraries which we have to install right away on the laptop or machine in order to complete this project. So let me talk about each and every package in detail, and let us understand why we are installing these libraries. Okay, so let us go for the first one, Pip Install Pandas. So Pandas is a data analysis library. So Pandas is very popular library for data analysis. Okay, so by using this Pandas, we will be also doing some little data analysis on the data, and also it is also very important when you want to read data from the CSV file, or if you want to correlate the data, or if you want to extract some columns, and if you want to handle some kind of independent and dependent variables, or if you want to extract the categorical data from the data set. So all that we will be using Pandas. So Pandas is very popular in terms of data analysis. And the second library is Streamlit. So Streamlit is one kind of library where you can easily create web applications. Okay, so I'm using Streamlit package. So pip install Streamlit, that will install the Streamlit on your machine. So Streamlit is nothing but, now in this project we are using Streamlit because we wanted to create a web application. Okay, if you want to create a web application, you can install Streamlit. If you don't want to create any web application, you can, there is no need of installing Streamlit. Okay, you can leave it. And the third library is sklearn. So we are using sklearn library. So this is a machine learning library. So by using this sklearn library, we will be training the machine learning models, and also we will be predicting the machine learning predictable outcome. So we have to install this library, which is called pip install sklearn. And also there is fourth library, which is a data visualization library. Okay, I'll be visualizing the data of the dataset by using this seaborn library. So I have to install this library as well. So these are the 4 libraries: Pandas for data analysis, Streamlit for web application, sklearn for machine learning, and seaborn is for data visualization. Hope you have understood why we are using this kind of libraries now. All right, so let us jump into the next slide. So let us explore the data set. Okay, so in the given data set, I will share you the data set, and the most important thing is the data set is already shared in my GitHub. The GitHub link is provided to the YouTube video description. You can download the data set from there. I will also show you sometime later. But according to this, okay, so according to the data set, so let me tell you some important things. So this data set is holding 9 columns. Okay, so this is holding 9 columns, and the attributes are written here in this table. So the first column is pregnancies. So this is the first column, which is called pregnancies. So pregnancies is nothing but how many number of times the patient was pregnant, and what is the type of attribute. So the type of attribute, according to me, so the user has to enter how many times the patient was pregnant. So which means that this is an independent variable. So this is an input variable. So this is an independent variable. So we have to consider this as a input variable. So the next, or you can say as feature, isn't it? So the second one is glucose. The second one is glucose. So this is also a second attribute. So this glucose is nothing but how much amount of glucose concentration was there for every 2 hours in the oral glucose tolerance test. So from the glucose test, we will be getting this value. So this is also an independent variable. Okay, so this is also an input variable. This is also a feature in the data set. And the third one was blood pressure. So what is the diastolic blood pressure? So this is also given as an input. Okay, this is also an independent variable. So that is the third column in the data set. And the fourth column is skin thickness. And the fourth column is skin thickness, which is nothing but tricep skin fold thickness. So this value is also taken from the test. So this value will be also entered by the user. So this is also an independent variable. So all these are independent variables. I have highlighted the dependent variable. Okay. So insulin. So the insulin is also the value which has been taken, which is like 2 hours serum insulin. So this is a value which is taken from the data set, and generally for diabetics patients, all this tests will be taken, and they will be recording all the values. So this value will also given as an input. And body mass index. So body mass index is also measured. So weight is measured, height is measured. Based on that, they will be calculating the body mass index. This is also an independent variable. You can able to see it there. And diabetics predictive function. So this is also DPF. So this is also been calculated based on the values which has been summarized in this data set. And this is also an independent variable. This value is also entered by the user. And age. So age of the user. So age of the user is also entered, and this is acting as an independent variable. So all these are independent variables up to now. And the last column is outcome column. So which is a Boolean value where you will have 0 and 1, which is like no and yes. So this is a outcome variable, and we will be So we will be taking this variable as an dependent variable. So this is like the outcome is totally dependent on pregnancies, glucose, blood pressure, skin thickness, insulin, body mass index, diabetics pedigree function, and age. So all these 9 columns are available in the data set. So I just wanted to give you an outline what kind of parameters are there, what kind of attributes are there. So there are 9 columns, out of which 1 to 8 columns are independent variables, and the last column is a dependent variable. So let us also do the data analysis on this, so that you can able to understand much better of this. Okay. So in the coming slides, I'll be also doing a data analysis, so that you can able to understand. So let us talk about stages of machine learning. If you want to develop any kind of machine learning project, so the most important thing is you should understand what kind of stages are there. So what is a machine learning life development cycle, right? So here I as an architect, I always look at this kind of machine learning life cycle. So where we have to collect data first. So data collection is very, very important. So the data collection is this. Data collection is very, very important, and generally we collect data. Okay. So after data collection, we have to prepare the data according to the business problem. So data will be prepared. Once the data is prepared, sometimes the data will have categorical data, or sometimes data will be missing, or sometimes you'll have irrelevant data related to the business problem. So we have to clean the data. So that is nothing but the third stage, which is called data cleaning. Once the data is cleaned, we will be going for data analysis. So data analysis is nothing but we will be analyzing the data, and from the data analysis we will be understanding a lot of things, okay, which is related to the business problem. So all these 4 D's, which is called data collection, data preparation, data cleaning, and data analysis, all this will happen on data. So and we will be coming to a conclusion in the data analysis, which attribute is important, which attribute is not important, okay, which column is categorical, which column is numerical. So we'll be understanding a lot of things from the data analysis. And also we will be understanding what is the distribution pattern between the input variable and output variables also. So from the data analysis. So once the data is analyzed, we will be training the model based on the data which is coming from data analysis. Once the model is trained, we have to test the data. We have to test the model by using test data. So we will be testing the model in the 6th stage, and once a model is tested, so it has to be evaluated. So we have to evaluate the model, which is like model evaluation, which comes in the 7th stage. Once a model is evaluated, if it scores greater than 70, or based on the business problem again, so immediately that model will be deployed. So these are the 8 important stages, which is called data collection. So we have to collect the data based on the business problem, and we have to prepare the data, and we have to clean the data, and we have to do analysis on the data. And forward that you have to create a model, and model has to be trained on the training data, a model has to be tested on the testing data, and model has to be evaluated. So we have to calculate the metrics, we have to understand how much model is accurate, and if the model is accurate good enough, then we can easily deploy it on the cloud platforms. So we will be going for model deployment. So today I have taken data set. Okay, no need to prepare data because dataset is already available. I have shared in the GitHub account. So to the video description, in the video description you can able to go to my GitHub and you can download the dataset from there. I will also show you how to download that, but that is where we have the dataset. So we have the dataset right away, and we have to do data analysis. We have to train the model, we have to test the model, and we have to evaluate the model, and we have to deploy the model, which indirectly means that we have to we have to analyze the model. Okay, so we have to train the model, we have to test the model, and we have to evaluate the model, and we have to deploy the model. So these 5 things you have to do. So which is from data analysis, model training, model testing, model evaluation, and model deployment. So all these 5 stages you have to do for this project, because already data is there. If data is not available with you, you have to collect data, and you have to prepare data, and you have to clean the data. Okay, so as of now this 5 steps are enough, so that we can complete the project. So let me show you. So from here data analysis will start, but before we start the data analysis part, let us download the data from my GitHub. Okay, so let me jump into my Google Chrome. Okay, I have Google Chrome on my laptop. So let me open my GitHub account. Okay, so github.com/mattblocksgit. So this GitHub account I have given in the video description. You can open that from there, which is mattblocksgit. Okay, so in the repositories, I have also given the repository link in the video description. You can click on that link. Okay, so there is a repository called Diabetics Prediction System YouTube Live. So this is the repository which I have created for this webinar. Okay, so this has entire project, but as of now let me download only dataset. So hope you are aware of dataset extensions, right? Dataset generally it will be in the CSV comma separated values format. So this is a dataset. So what I'll do is I'll download this dataset. Okay, diabetes.csv onto my machine. Okay, so this is a dataset. So what I'll do is I'll just click on that, and I will click on download. Okay, or you'll have some kind of, okay, so here also you can able to see the dataset. Okay, so it has, okay, let me zoom it for you. So it has pregnancies, glucose, as we discussed, how many times the patient was pregnant, and glucose value, blood pressure value, skin thickness value, insulin value, followed by insulin value, followed by body mass index, followed by diabetes pedigree function, followed by age, followed by outcome. So these are the columns as we discussed earlier in the previous slides. So let me download this data. Okay, we have to click on this. So here you will have view raw. So you can click on this icon. Okay, so when you click on this icon, you'll get something like this. Okay, you'll get something like this. What I'll do is I'll just right click here, and I'll click on save as. Okay, I'll click on save as. So then immediately a window will open. Now here what I'll do is I'll simply create a folder on my desktop. Okay, I'll create a folder on my desktop. Let me zoom it for you. Okay, I'll create a folder on my desktop. Okay, I'll put something like YouTube live diabetics prediction system. Okay, so in that I'll save this file. Okay, in that I will save this file, which is called diabetes. Okay, this is a comma separated values file. Okay, you can save it. Okay, now the dataset file was saved. Okay, it is simple. What we have to do, we have to right click here and we have to click on save as. So when you click on save as, immediately you'll get this window. So on this window, what you have to do, you have to click on save. Okay, but before you save, you have to create a folder on your desktop or somewhere where you want to save this project, and you have to click on save immediately. The diabetes dataset will be saved. Okay, so here I'm using two platforms. Okay, so I have this dataset on my laptop now. Okay, this dataset I have uploaded to my repository, and the repository link is there in the description of this video. You can able to get the dataset from there. Okay, so now the most important thing is, let me go back to my presentation. So as per the presentation, I'm using Google Colab for data analysis. Okay, I'm using VS Code for implementing the project. So to understand the data which is there in the dataset, I'll use Google Colab for data analysis part. Okay, and Google Colab is a Google collaborative Python notebook where it is running on Google Compute Engine, which is associated with your Gmail account. So you can open your Google Colab directly. So the link to open Google Colab is collab. You can search Google Colab on Google, so you'll get the link. Okay, that is not so important, but I can show it for you. Okay, which is Google Colab. Okay, which is collab.research.google.com. okay, which is collab.research.google.com. so this is the URL where you will have to open collab.research.google.com. okay, in this Google Colab, what we have to do is we have to click on file and new notebook, so that a notebook file will be opened. So it's very simple, file and new notebook. So immediately a Colab notebook will open. So let me zoom it for you. Okay, let me zoom it for you, and let me replace the name of the notebook so that later I can able to share this in the GitHub profile also. So Diabetics Prediction System Data Analysis. Okay, so the extension is .ipynb. so this is the Python notebook extension. Okay, so here what we have to do is we have to click on connect. So when you click on connect, then only it will be connected with Google Compute Engine. But to access this Google Colab, you should log in with your Gmail ID. So I guess you can able to see my photo here, which means that it is logged in. So my Google Colab is logged in with my Gmail ID. So if you have Gmail ID, you can simply log in into this. Okay, so Google Colab. So here what we have to do is I'm going to use this Google Colab for doing data analysis part. So here what I'll do is I have the data set available on my laptop. Now I'll upload to the session storage so that I can able to access the file from there. So to access that we have to click on the folder icon. Let me zoom out. So here you will have a folder icon. So this is like file manager. So you have to click on this. So when you click on this, immediately session storage will open. So here you will have upload button. So I'll click on the upload button. So this is like uploading the file. So up arrow is there. So when you click on this up arrow, immediately a box will open. So here you have to browse to the dataset file, and that dataset file is available on my desktop. So I'll just go to my folder which I've created now. So I'll select the dataset and I'll click on open. So when I click on open, immediately that dataset will be uploaded to the session storage where you can able to see it here. So this is nothing but diabetes.csv. so this is a file which I have uploaded from my file manager. Okay, from my files which I have saved it on my machine. Now the diabetes.csv is uploaded to the session storage so that Google Colab Python code can able to access this file. Okay, so let me close so that it is hidden. Okay, but the file is there in my session storage. To open, to see that you can type something like let us open that file using pandas. Okay, so import pandas. So let me zoom it for you. Okay, import pandas as PD. So we are importing pandas. Pandas is a built-in on Google Colab, so that is why I'm using this. Okay, pandas is a built-in library. on Google Colab. So I'm just importing pandas as PD, and also after this what I'll do is I'll just read the data from the data set. Okay, so we have a CSV file. So let me have something like data equal to pd dot read underscore CSV of the name of the file. Okay, what is the name of the file? Let me I guess it is nothing but diabetics.csv. Okay, so this is the name of the file. Let me run this play button. Okay, it will run the cell. So when you run the cell, okay, I guess I have written a spelling mistake. Okay, it is just diabetics.csv. Okay, so if the file name was wrong, okay, it is, you'll get error. But if the file name is right, if you open the same file, like if you have written the same file name, then immediately no error. Okay, so what we are doing, we are just reading the data from CSV file. What is read underscore CSV? Read underscore CSV is nothing but it's a built-in method of pandas which is reading data from the CSV file. When it is reading the data from CSV file, it will be read as a data frame. Okay, so there is a data frame is nothing but a data structure of pandas, which is nothing but a matrix representation of data. So your data will be represented in different rows and columns. Okay, that is how a data frame will be created. Okay, so whenever you read data from the CSV file, not only the CSV file, you read data from any CSV file, it will able to read data in terms of data frames. Okay, now data is nothing but data frame, which is a pandas object. Now let me show you that. Okay, let me print data. Let me type just data, and when you hit this play button, immediately you can able to see. So data is nothing but if you see, it is printing all the data. So you can able to see that there are 468 rows and 9 columns. So which means, as I said, as we discussed in the presentation also, there are 9 columns. Okay, and starting from pregnancies to outcome. So there are 9 columns here. How many rows are there? 768 rows are there. So which means that 768 samples are there. Okay, by using this 768 samples, we have to create a machine learning model. Okay, so we have to create a machine learning model based on the 768 rows and 9 columns. So here every row will be assigned with an ID called index called 0, 1, 2, 3, so on. Okay, so here when pandas, as I said, it will be reading data in terms of data frame. So what is data frame? Data frame is nothing but matrix representation of data. So indirectly means that you'll have rows and columns. So every row is indexed with index value. So if you see, the index value is 0 for the first row, and for the second row it is 1, 2, 3, so on, 767, because we have 768 rows. As the index is starting from 0, so the last index value is 767 only. Okay, and it is also having 9 columns, and each column has a column name which is like feature. So pregnancies, glucose, as we discussed, pregnancies, glucose, blood pressure, you can able to see. Okay, so let me run a cell called data.columns. Okay, so data.columns is nothing but which it will give you all the column names. Okay, so what are the column names available here? Pregnancies, glucose. Okay, pregnancies, glucose, blood pressure, skin thickness, body mass index, diabetes pedigree function, age, and outcome. Okay, so when you run a command called data.columns, so what it will do, it will just show you what are the column names available. Okay, so what are the columns available in the data set. So it will be helping you to understand what are the columns, what are the features, what are the attributes available in the data set. So all these attributes we have discussed in the previous slides. So we have explained that what is input variable and what is output variable here. So when you look at this columns, pregnancies is an input variable, glucose is an input variable, blood pressure is input variable, skin thickness is input variable, body mass index is input variable, diabetics pedigree function is input variable, age is also input variable, and outcome is an output variable which is called dependent variable. Input variables are also called as independent variables, and outcome is called dependent variable here. So let us look at what are the data types, okay, of these columns. Okay, so that if there is any categorical data, we can able to manipulate it. So data.d types, so where it will give you the data types of the columns. Okay, so if there is any categorical data in the data set, for example, say in this data set we have all integer and floating point, which is like numerical data type, right? So so some columns are having integer data, some columns are having floating point data, which means altogether it is a numerical data. So since it is a numerical data, there is no need to worry about it. If sometimes whenever you're uploading the data, whenever you take a data set which is some of categorical type, then we have to convert that categorical type into numeric type. We have to use encoding methods and all that in order to convert that categorical data into numerical data. And also let us understand, is there any missing data available? Okay, so if you want to understand missing data, okay, if you want to understand the missing data, whether we have any missing data or not, because whenever you have missing data, you cannot give that data directly to the machine learning model. So we have to understand, we have to analyze whether we have a missing data or not. If you want to check that, data dot is null dot sum, so it will give you if there is any missing data available. Okay, so if you have missing data, you can replace with mean value if it is a numerical column, or if it is a categorical column, we have to replace with frequency. All this, there are different types of techniques, okay, for data cleaning or data analysis. So we'll discuss that in a later video, but as of now, I'm just checking out whether we have any missing data available. So pregnancies, there is no missing data. Glucose, no missing data. Blood pressure, no missing data. All are zeros, so which indirectly means that there is no missing data available in this data set. If you have missing data available in the data set, we have to do mathematical implementation on this missing data. So here there are 2 points which is very clear. One is like there is no categorical data, there is no string data, there is no categorical data, and there is no missing data here. Okay, so let me extract the first 5 entries from this data. Okay, so which is like data.head. So data.head is nothing but it will give you the first 5 entries, because it is difficult for us to go through all these 768 samples, right? So that is why what we'll do is, sometimes people write data.head, or data.head is nothing but it will give you the head frame, which is nothing but the first 5 rows. So 0 to 4 is nothing but first 5 rows. If you have some logic, if you write something like data.tail, so you will get last 5 rows. Okay, last 5 rows. So if you want to go through last 5 rows, you have to use a command called data.tail. If you want to see the first 5 entries, then you have to go for data.head. So data.head is nothing but the first 5 entries, and data.tail is nothing but the last 5 entries here. If you want to go through the data set of only one item, say data.head of 1, so it will give you only the first entry. Okay, so data.head of 1 is nothing but if you specify some value, based on that it will give you it will give you the entries. Okay, so data.head of 1 is nothing but it will give you something like for the first entry, which is this. Okay, there is one more thing which we have to understand, is data.describe. Okay, we have to look at the summary. Okay, so we have to look at the summary. So how many samples are there for pregnancies? There are 768 samples. For glucose there are 768. So I guess the number is same for all the columns, and we have to look at what is the mean value, what is the standard deviation, what is the minimum value. Okay, so what is 25% value, what is 50%. So this is a historiographical representation of the data which has been in the data set. So all the 9 columns, okay, all the 9 columns will be evaluated. Okay, you can able to see here, I have zoomed out. So pregnancies, glucose, blood pressure, skin thickness, insulin, body mass index, diabetes pedigree function, age, and outcome. So all this we have, it has calculated what is the standard deviation, what is the mean value, what is the how many counts, how many samples are there, what is 25% of values, what is 50% of the values, what is the maximum value even. Okay, so all this it will be giving you a summary to understand how the data was distributed. Okay, and also let us plot the graph. Okay, so let us plot the graph. So to plot the graph, I will be using Seaborn library. Okay, so import Seaborn, I guess that is also built in. Okay, so that is also built in on Google Colab. Okay, let me zoom it for you. So sns.pairplot, I'll be using pairplot in order to understand the distribution of this data across all the parameters. So data comma virus variable. So what are the columns here? So one is pregnancies, okay, comma glucose, comma blood pressure, comma skin thickness. So all these are the various parameters, right? Various attributes: skin thickness, insulin, body mass index, diabetes pedigree, function, age, outcome. So these are the different types of attributes. So after this, what I'll do is, if there is any missing values, okay, you can drop them. So I'll use drop na equal to true, so that if there is any nan values, it will drop. But as of now, I don't think I'll get nan, because there is no missing data available. Okay. Now based on this graph, now it will be plotting the pair plots, okay, between the attributes. So it will take a minute. So let us wait until the plot is plotted. So pair plot is one kind of data visualization technique to understand the distribution of data among the other attributes, okay. Yes, it is creating a grid now. Okay, so it has created a grid. Let me open it in the new tab, okay. Okay, so this is the pair plot which I have opened it in the new tab, okay. So let us go for the first one, okay. So if you see, there is a histogram representation of this. So this is pregnancies versus pregnancies, okay. So what happened in the pair plot was, it was plotted the data, okay. This is pregnancies versus pregnancies. This is like pregnancies versus glucose. This is like pregnancies versus blood pressure, and this is like pregnancies versus skin thickness, and this is like pregnancies versus insulin, and this is like pregnancies versus body mass index, and this is like pregnancies versus pedigree, diabetes pedigree function, DPF, and this is like it is between age and pregnancies, and this is outcome and pregnancy. So what happened here? So one attribute is plotted, one of the first attribute is taken on y-axis, and the remaining attributes are taken on x-axis, so that we can easily understand the distribution of data of this data set, okay. So now if you look at this, okay, so now if you look at this, we can easily come across to a conclusion that all the attributes are uniformly distributed across the data, okay. And the most important thing is that there is no unwanted data here, okay. So we have to consider all the attributes, okay. So we have to consider all the attributes, because every attribute, for if you take one attribute and the other attribute on x-axis, then obviously when you plot that, every attribute data is scattered across the graph, so which indirectly means that we have to consider all the elements, okay. So we don't want to miss any data item here, so we have to consider each and every attribute in the data set, okay. So this type of conclusion we have to, let us save this, okay, so that I can share it in the GitHub, okay. So this is a pair plot. So we came to a conclusion that we have to include all the parameters to create a machine learning model, okay. So let me download this, let me save this, okay. Okay, so I have downloaded this Jupyter notebook. I'll just share this on Git, okay, so that if you miss any command in this, you can able to type that same, okay. So let me jump into VS Code. I'm okay with the conclusion. Let me open VS Code. Okay, let me in the VS Code, what we have to do is, in the VS Code we have to click on file, okay. So when you click on file, you will have an option called open folder. So we have to click on open folder. So when you click on open folder, immediately this will open. So here what we have to do is, we have to go to so we have to go to desktop, because on the desktop we have this folder. So on the desktop, what is the folder name which I have created? I have created something like YouTube Live DPS. I'll just select this and I'll click on select folder immediately. So that will be opened. Okay, now you can be able to see here. So you could able to save YouTube Live DPS. So I have a dataset file and I have a PNG image. Okay, so this is the pair plot image which I've downloaded from the Google Colab. Okay, so this is not so much required. Okay, but I just downloaded because I just wanted to upload this to my Git. Okay, to show you that this was a this was a distribution of data attributes. Okay. Now here what we have to do is we have to create a Python script. To create a Python script, what we have to do is we have to click on the first plus icon. Okay, so whenever you click on first plus icon, what it will do is it will just asking you to enter some file name. So what I'll do is I'll write app.py. Okay, I'll go for app.py. App.py. Immediately when I hit enter, immediately this Python script will open. Okay, so here I'll write a Python script which creates a machine learning model, which trains a machine learning model, and which tests, which evaluates. So all the process I'll write one by one in this app.py. Okay, so let me zoom out for you. Okay, so give me a minute, I'll just increase the font size. Okay, where is this? Okay, now let me write some program. So here what we have to do is we have to import pandas again. Okay, so we have to import pandas as PD. Okay, and data equal to okay, so let me write the program. Data equal to pd dot read underscore csv. It is giving recommendations also. You can able to see it there. Okay, so pd dot read underscore csv of data which is like diabetes.csv. So I'm searching for something else. Okay, so anyways I can write program here. Data equal to pd dot read underscore csv diabetes.csv. So it will be reading all the data in terms of a data frame. Now here what we have to do is we have to separate input and target variables. Okay, so here we have to separate input and target variables. So here what we have to do is input variable generated machine learning, they are denoted with x. So x equal to data dot ilockup. So here you have to talk about every row. So every row is nothing but colon. Colon indicates all the samples has to be included, which is nothing but all rows has to be included. And here it has to start with 0, because here input is nothing but every column other than the last column. So you can say it as 0 colon minus 1. So 0 colon minus 1 is nothing but start from 0th column excluding the last column, so which is like 0 colon minus 1 dot values. And also you have to denote the target variables as y. So this is also same data dot iLoc of every row which is last column, which is nothing but minus 1 dot values. So we have separated input and output variables, okay, and this input and output variables, so everything is fine. Now what we have to do is we have to create the machine learning model. So to create a machine learning model, okay, to create a machine learning model, and we have to look at the target data. So here we are going for a machine learning model called we have to go for supervised machine learning models only. Okay, why we have to go for supervised machine learning model? Because we are giving the label data, right? So when we are giving the label data, so we have to go for supervised machine learning models. When we don't have any label data, then we have to go for unsupervised machine learning models. So in supervised machine learning models, again there are two types of algorithms will be there. One is called regression and second one is called classification. So regression and classification. So regression is also a supervised machine learning model. Classification is also a supervised machine learning model. So we have to go for classification, because here the outcome, if you see, that is a discrete outcome, right? You will have 0 and 1. So which is nothing but they are labels. They are like classes, class 0, class 1. So which is like discrete. So when you have a discrete outcome, or if you have something like categorical outcomes. So if you have a categorical outcome, then you have to go for classification algorithms. If you have a numerical outcome, something like predicting a salary, or predicting a home rent, or predicting a movie ticket price, or predicting a bus fare, or predicting a trial fare, or predicting a airfare, then all this comes under regression, right? So regression is an algorithm where you have to go for it when you want to predict a numerical outcome. If you want to predict a categorical outcome, something like 0 and 1, something like yes or no, then you have to go for classification algorithms. Okay, so this is a brief because you should have a basic knowledge on machine learning algorithm before you implement this project. Okay, so here we are going for classification algorithms. In the classification algorithm particularly, I'm going for Knm, because for Knm only this dataset is giving a better outcome. So I'm just going for Knm classification algorithm. Okay, Knn, let us talk about Knn a while, and then slowly we'll jump into the implementation part of this. Okay, so Knn classification. So what is this Knn classification? Nn is nothing but nearest neighbor. So this Nn is nothing but nearest neighbor. Okay, so based on the nearest neighbors, so this is going to predict to which class it belongs to. Say we have two different classes here. So I've taken an image where you will be understanding the basic outcome of Knn classification. So there are two types of classes. One is like class with blue squares, and one class with red triangles. Okay, so there are two types of classes, one with blue squares and one with red triangles. Okay, so there are two classes here. So that data is scattered across the graph. Okay, so and now what we have to do is we have to predict this green circle. So we have to predict this green circle in such a way that to which class it belongs to. Does it belongs to blue square? Does it belongs to red triangle? That is what we have to predict. Okay, so now we are applying a Knn classification. So k is nothing but number of nearest neighbors. Okay, so let us have k equal to 2. So let us have k equal to 2. So when you have a k equal to 2, then identify who are the nearest neighbors to it. So the nearest neighbors, if you see, when k value is 2, these two are the nearest neighbors, isn't it? These two are the nearest neighbors. And when you have k value 3, and these 3 are the nearest neighbors. So when you keep changing the value of k, more number of neighbors it will include. Okay, if k value is 2, it will identify who are the two nearest neighbors. So here if you see, we have, when k value is 2, there are two red triangles near to it. So which indirectly means that this green circle belongs to this particular class. Okay, so it belongs to red triangle class. If you have more, if you have more blue squares near to it, then obviously it belongs to blue square. So that is what it says, that So Knm classification, it will try to identify based on sometimes people use Euclidean, sometimes people use Minkowski distance. So people use different distance metric method in order to identify the distance between the objects. Okay, so you use any kind of distance metric, but people use that, people measure the predict the target variable based on the distance between the objects. When the k value is 2, so these two are nearer. When k value is 3, these three are nearer. So say if k value is 3, okay, so we have two red triangles, we have only one square, then immediately it means that this green circle belongs to red triangle because there are two red triangles here and we have only one blue square. So this is what Knm classification is all about. Okay, so we will be also implementing Knm classification here. Okay, we will be implementing Knm classification here, and we have sklearn library. Now what I'll do is I'll just import sklearn. Okay, from sklearn I'll import neighbors. From this neighbors I'll import a class called Knm neighbors classifier. Okay, Knm neighbors classifier. So this is a class which is defined in neighbors module. Okay, so I'll create, so this is a class, so we have to create an object, say classifier equal to k neighbors classifier. Okay, we have to pass how many number of what should be the value of k. So if you don't pass anything, so the number of neighbors will be 5 by default. Okay, if you pass anything, then obviously it will change according to that. Okay, so now we have created a classifier. Now what we have to do, we have to train the classifier, right? So we have to train the classifier. We have x data and we have y data. So now what I'll do is, sometimes people split the data into training data and testing data. Now I'll pass the entire data. Okay, so here what I'll do is I'll simply pass the entire data, which is like classifier dot fit of x comma y. So I'll pass the entire data, which is x and y. So the classifier will get trained. Okay, so now here what I'll do is I'll simply test the classifier. Okay, I'll simply test the classifier because we have input data which is called x, right? So when it is predicting the outcomes, let's say y underscore pred. Okay, y underscore pred equal to classifier dot, I'll be predicting the same input variable. Okay, I'll take same x values. Okay, I'll simply predict. Okay, so when it is predicting, so the y underscore pred is nothing but the predictable outcome. Now what I'll do is I'll just compare this y underscore pred and y. Okay, so if y is equal to y underscore pred, then obviously 100% it was matched. And let us understand what is the accuracy score. Okay, to get the accuracy score, there is a method in sklearn, from sklearn.metrics. So there is a module called metrics, import accuracy underscore score. So by using this, what I'll do is I'll simply calculate the accuracy score of the model. So accuracy score in between y underscore pred and y. So it will be printing the accuracy score. So let me run this program. Okay, let me run this program. So you can hit the play button. Okay, immediately the program will be running and it will print the accuracy score. Okay, so now it is saying that 0.80, which is nothing but 80.33% the accuracy was there for this machine learning model. So which is pretty enough. Okay, so you can also check it with random forest or decision tree. You take any kind of classifier, so the process will be same, right? The process of implementing it will be same. So you can also implement it. Instead of k neighbors classifier, you can use decision trees or you can use random forest. That is up to you. So I'll leave that for you and you can do it. Okay, so I have printed the accuracy score, so that is fine enough. Now accuracy was there, 80.33 was the accuracy score. Okay, let me zoom it for you. Let me show you the accuracy score, what I have achieved. Okay, so you can able to see here. Okay, there was this problem with zoom. Okay, so you can able to see here 0.8033854. So that was the accuracy score. Okay, now here what I'll do is I'll simply use Streamlit. Okay, now so I have created a machine learning model, I have trained it, I have tested it, I have evaluated it, I have calculated what is the accuracy score of it. Now we have to import Streamlit. Okay, so let me import Streamlit. So I have installed all these packages. I have given you the commands also how to install these packages earlier in the slides. So import Streamlit as st. Okay, so I just wanted to create a web application. Okay, so what I'll do is I'll simply give some heading for this web application, st.header. Okay, I'll write some st.header. So st.header, which is nothing but giving some heading to the web application. So let me write some heading, something like diabetics prediction system. Okay, so this will be heading. Let me run this file. Okay, so let me run this file. Let me see whether web application is created or not. If you want to if you want to run this program, so this was the function, this was the command. Okay, so we have to use streamlet run app.py, otherwise it cannot able to run the program. So we have to give this command here, streamlet run app.py, then immediately streamlet will be running this program, which is app.py. So here I have just created some heading. Okay, so I have created some heading, so let me show you that. Okay, so here you can able to see, so diabetics prediction system. Okay, so this was the heading which we have created in the Python program. Okay, so here we have to create our we have to take some user inputs, right? So let us take the user inputs one by one. Okay, so this was the heading which we have given. So let me write something like pregnancies equal to st dot text underscore input of enter pregnancies. Okay, so we are just taking the data. So let me save it. Let me go back to Google Chrome. Let me see. Let me reload the page. Okay, let me see whether it is yeah, it has pasted enter pregnancies. You can able to see it here. Okay, enter pregnancies. So like this we have to create multiple inputs. Okay, so pregnancies, after pregnancies, which is glucose equal to st dot text underscore input of enter glucose value. Okay, like this we are giving some form, so that the attender or admin can able to enter this data. Okay, so that he will be passing this data to the machine learning model. So after glucose, it is blood pressure. So blood pressure equal to st dot text underscore input of enter blood pressure. So one by one we have to take skin thickness equal to st dot text underscore input of enter skin thickness. So this is a tricep skin thickness. After that we have to enter something like insulin. So st dot text underscore input of enter insulin. After this we have to enter something like body mass index. st dot text underscore input of enter body mass index, enter BMI. So DPF, which is diabetes pedigree function, st dot text underscore input of enter diabetes pedigree function value. Okay, and also let me take one more attribute called age equal to st dot text underscore input of enter age. Okay, so these are the different attributes. Okay, let me count whether I have got 8 or not. Let me go to Google Chrome. Let me reload this page. So when I reload this page, you can able to see enter pregnancies 1, enter glucose 2, enter blood pressure 3, enter skin thickness 4, enter insulin 5, enter body mass index 6, enter diabetes pedigree function 7, enter age. So we have got 8 forms. Okay, 8 text inputs, so that people can able to enter this data here. Now what I have to do is I have to create a button. Okay, so let me create a button here. If st dot button of predict, say if this button is pressed. So if this button is pressed, it will return boolean value called true. If it say I'll write some st dot warning, I'll give some hint. Okay, predicting the data. Okay, so let me reload. So whenever this button is pressed, immediately st dot warning, which is like warning message, will be displayed there. Let me show you that. I'll just hit predict button. Okay, so when I hit predict button, you can able to see it is displaying that predicting the data. Now I have not entered the data, but I'm just testing here. Okay, predicting the data. So that is been printing. So now what we have to do is we have to collect the data. Okay, so we have to collect the data. So input data equal to we have to create double square bracket because 2D array we have to pass. So pregnancies comma glucose comma, so what is the next, blood pressure comma skin thickness comma insulin comma body mass index, diabetes pedigree function, age. So these are the 8 inputs we have taken, and this input data what we have to do, we have to pass to the classifier. Okay, so what I'll do is I write classifier dot predict of input data. So I'm passing to the classifier, and the classifier will be predicting whether it is true or false. Okay, which is like, it will be assuming that, so that will give you a boolean value. Okay, so it is predicting the input data. Whenever it is predicting the input data, it will give you some boolean value which is 0 and 1, which is the outcome. It is predicting the outcome now. So it will be in 1D array, so we have to write square bracket 0 because it will be in 1D. So now what I'll do is I'll simply have an input, I'll have something like, a conditional loop here. If this value is double equal to 0 or just colon. Okay, if that value returns 0, then immediately it goes to else, right? So st dot success, so I'll write no diabetes. Okay, or simply I'll write double equal to 0. Okay, no, if it is 0, it is not no diabetes. Else st dot warning, so immediately it goes to diabetes found. Okay, if the value is 0, 0 double equal to 0, it will become true, so there is no diabetes. So let me save this file, let me rerun the program. Okay, so what I'll do is I'll simply pass input data. Okay, enter pregnancy, say I'll pass pregnancies values as 6, glucose value which is like 148. Okay, blood pressure I'll pass something like 72, skin thickness I'll pass something like 35, insulin I'm taking this data from the data set. Okay, 0, body mass index 33.6, diabetes pedigree function 0.627. Okay, age is 50. Okay, I have entered all this. When I click on predict, okay, so when I click on predict, it should say diabetes was found. Okay, because that is a sample which is taken for diabetes found. Okay, so that is a data which has been taken for one case. So which is like, I'm getting diabetes found because this patient is having diabetes. Okay, because this is the data which is taken from the data set. Okay, and let me enter other values, something like 1, glucose value is 85, blood pressure is 66, skin thickness value is 29, insulin value is 0, body mass index is 26.6. Okay, diabetes pedigree function is 0.351, age is 31. Okay, when I click on predict, so it should say no diabetes. Okay, so saying that this patient is not having any diabetes. So I'm getting this output. Okay, so it is running on local host. So I have to deploy this because everything is running good. I have to deploy this on Heroku platform. So let me jump into Heroku. Okay, so I guess according to my presentation I have completed all this. Okay, I'm done with loading data set. I have separated input and dependent and independent variables. I have created a classifier. I have trained the model. I have tested the model. I have evaluated. I have created a user interface, and I also collected data from user, and then I have passed it to predict method also. So and then we have to deploy. So to deploy, what we have to do, we have to log into Heroku platform. Let us do that. Okay, so let me open the Heroku platform on my browser. Okay, so let me open Heroku. Heroku is nothing but heroku.com. Okay, you can open the website of Heroku. So make sure that you have an account here, otherwise you cannot deploy. I'll click on login because I have already have an account here. Login, let me provide all the details. Okay, my user details. So I have a token. Okay, let me enter my verification code. So it will be sent to my authenticator. Give me a minute, I'll just enter my details. On authenticator, let me enter my verification code. Okay, 219039. So that is my verification code. Let me click on verify. So immediately, it was logged in. So here what we have to do is we have to create an application. Okay, we have to create an app. So to create an app, now the Heroku platform was opened. Okay, now Heroku platform was opened. So here we have to deploy our machine learning model. So what we have to do is we have to click on new. Okay, so we have to click on new. So whenever you click on new, you will get some option like create a new app. So you have to click on create new app. Then immediately it will be asking to enter the application name. So the application name, you have to provide the unique name. Okay, say something like Maddy YouTube live diabetes, something like that. Okay, you have to provide unique name. So if it is available, it shows that it is available. If not, it will show it says that it is not available. Okay, so region can be United States, that is fine. So we have to click on create app. So in Heroku platform you can deploy 5 projects. Okay, so now I'm deploying one project, create app. So now the app will be created. Okay, now the app was created. Now what we have to do is we have to deploy our machine learning project to here, but to deploy that we have to do certain file structure. Okay, so in order to deploy this, we have to do a little file structure. Okay, so we have to create a file called requirements.txt. Okay, so I'll show you in my git. Okay, I'll show you in my git. Give me a minute. Where is my git? Yeah, so if you see so you have to create something like this, requirements.txt. Okay, so this requirements.txt, what it will hold is it will hold all the packages which we have used in the program. Okay, so we have used pandas and we have used Streamlit, we have used sklearn, numpy. Anyways, that's a numerical Python library. It will be installed with sklearn, no need to write again, but if you want to write you can also provide it. Okay, so we have to create something like this. Okay, so let me copy all this. Okay, for timing I'll copy all this. I'll create a file here. Okay, I'll click on plus. I'll provide a name called requirements. We have to make sure that there is no spelling mistake on this. Okay, so it will search for this file, requirements.txt. Okay, so requirements.txt, so there is no need to provide pandas. Okay, so that is fine enough. So pandas, numpy. So numpy is not mandatory here because numpy will get installed with sklearn. Pandas, Streamlit, sklearn. So these are the libraries which we have used. Okay, in app.py, if you look at, so these are the libraries, right? Streamlit, sklearn and pandas. So these libraries we have just installed, so that is why we have to provide in requirements.txt. The most important thing, sometimes what people commit a mistake is that they provide a different name. Okay, so your name should be requirements.txt, because whenever the Heroku deployment platform, whenever you deploy a project, it will search for this file called requirements.txt. Okay, so make sure that that this file is created properly. So along with this, we have to create for Streamlit, we have to create one more shell scripting file which is called setup.sh. Okay, so this is a shell scripting file. What we have to do is we have to copy paste all this for Streamlit. So this is according to the Streamlit documentation. Okay, so nothing logic is there. It just creates a directory called Streamlit, and then it will hold the server, because Streamlit is nothing but a web server. It will be running on Heroku platform now. So it will take all the port numbers and it will forward it to the Heroku API URL. So we have to copy all this and we have to create a file. Okay, now we have to create a file called setup.sh. Okay, setup.sh. So this is a shell scripting file. Okay, we have to paste everything what is copied from my GitHub. Okay, this is the so the name of the file, make sure that it is setup.sh. So setup.sh is nothing but shell scripting file. Okay, so this is created. Along with this, we have to create a proc file also, that is a deployment file. So for Heroku platform, there will be a proc file. So proc file. So what we have to do is we have to provide the same name. Okay, so it is totally case sensitive. We have to provide the same name. So we have to create a proc file. Okay, so let me click on plus. Let me write proc file. So proc file is a Heroku deployment file. Okay, so we have to create that file and we have to copy paste this. Okay, so this is nothing but what it is saying is that Heroku platform, we are giving a hint that we wanted to deploy a machine learning model, but indirectly we are saying that we wanted to have a web application, okay, and we are asking the shell to run setup.sh first, okay, so that it arranges the streamlit packages and all that. After that, we are asking the Heroku platform to run app.py. App.py is nothing but the name of the Python script which we have created, where we have written all this program, okay. So all this we have to copy it. Now the Heroku platform will understand that, okay, so this developer is wanted to deploy a web application, and they wanted to run setup.sh first, and later it is streamlit run app.py. Immediately the web server will be launched and you can able to access it from globally. Okay, let me so make sure that you have git, okay, make sure that you have git here. Otherwise, if there is no git, then you cannot able to deploy this project. And also Heroku CLI, I'm using Heroku CLI now, Heroku command line interface. We have to install that Heroku CLI here, because there are three options which are provided, out of which two are very popular. One is Heroku CLI and second one is GitHub. You can upload this repository to Git and later you can deploy it by using GitHub, but now I'm using Heroku Git, okay, Heroku CLI. So I'll click on this Heroku CLI. It will go to the you have to install the Heroku CLI, but on my laptop it was installed. So I'll just type this command Heroku login, so that you can able to log into Heroku CLI. Okay, this is for security, okay, this is for knowing that who is deploying the files, okay. So press any key to open up the browser. I will press any enter, so that browser will open. So immediately it will open the browser and it will ask you to log in, okay. So since it is already logged in, there is no need to log in. You have to click on login. So when you click on login, immediately it says that you are logged in, okay. So which means this is a small security authentication, okay, no need to worry about it. So it means you are logged in, okay. Now here we have to so everything is done, okay. I'm just closing this editor, okay. So everything is done. We have to go for deployment, okay. So let me zoom. So we have to follow certain steps here, okay. So what we have to do is, so we make sure that git is installed, okay, git init. So git will be initialized. So we have to go for, we can use the same commands here as specified here, okay. After that you have to copy this and put it on the terminal immediately, so that remote repository will be added to your git. After that you have to add every files. So you have to click on this copy and paste, okay. So it is just copy paste, okay, for you to, if you're a beginner, I am just showing all this, okay. Otherwise I will follow my own GitHub commands, okay. So it will commit all the files, it will be added to the stacked repository. So from there it will be passed to the remote repository, which is like git push Heroku master. Then immediately it will be pushing the files to the remote repository. So on the remote repository, whenever these files are received, then immediately we have a deployment file called proc file. Then immediately what it will do is, it will install all the requirements according to requirements.txt, and later according to the proc file. So this will be deploying the web server, and once a web server is launched, when everything is launched, then obviously you can able to access through app. So it is installing all the packages. It is installing, let us wait. Okay, so everything is getting done and the application is launching. So let me open this. Okay, let me open this on my Google Chrome. Okay, so immediately it will go to Streamlit. Okay, so you can able to see the same thing. Okay, diabetes prediction system. So let me enter all the values once again. Okay, so let me enter the values like 6, 148 again, blood pressure was 72, skin thickness was 35, insulin was 0, body mass index is 33.6, pedigree function 0.627, and age was 50. And when I click on predict, immediately it says that diabetes was found. Okay, so let me have something like which is the second case, which is no diabetes. Let me have one. Glucose value is 85, blood pressure is 66, skin thickness is 29, insulin is 0, body mass index is 26.6, and diabetes pedigree function is 0.351, age was 31. Okay, so when I click on predict, it says that diabetes not found. Okay, no diabetes. So which indirectly means that this particular web application is predicting whether you have diabetes or not based on the diabetes diagnostic reports. Okay, so based on these attributes, it is trying to predict whether you have diabetes or not, whether the patient has diabetes or not. So the main intention is that we are providing the data from the Heroku application, and that data which we have entered here is passing to machine learning model through a simple Python script, and that machine learning model is predicting the outcome, and that outcome is coming back to this Streamlit interface. And here after predict, we are showing the result as whether he has diabetes or not. Okay, so this is a project implementation. Hope you have understood each and everything in detail. If you are any confused, if you get any confused in implementing this, while implementing this, you can send me a message in the Telegram, or I hope you have my LinkedIn profile also. You can send me a message on LinkedIn. I can reply you either on Telegram or on LinkedIn if you have any question to ask, or if you face any difficulty in doing this project, you can reach out to me. Okay, so this is the simple project which I have taken for implementing a machine learning project today. Okay, there are more machine learning projects which are in pipeline. Okay, I'll be coming live every week. I'll take every one day for explaining your machine learning project. Okay, so I guess that's all for now. If you have any doubts, you can reach out to our Telegram group, and if you want to talk with me, you can stay connected with me on LinkedIn. So this is my URL, linkedin.com/in/MadhuPIOT. You can search LinkedIn, you can open LinkedIn and you can search for Madhu Parvathineni. You'll get my account. You can stay connected with me. You can send me a message out there. So that's all for today. Please like the video if you like this project, and please subscribe to our YouTube channel if you have not subscribed yet, because there are interesting videos and webinars coming up. Okay, so tomorrow also we are streaming one video which is on MongoDB database, and on Friday also I'm coming live again to show you a project called Alexa controlled IoT lamp. On Sunday also I'm coming live to talk about how to launch a virtual machine on Microsoft Azure. So there are a lot of events coming up, okay, which are in pipeline. So please subscribe to our YouTube channel and motivate me. Okay, so thank you for joining me live, and also whoever watched this video later, thanks for watching till the end. And most importantly, always keep learning, keep doing projects, keep building your profile. Okay, so stay motivated, stay safe, keep doing things. Thank you. Signing off. Good night and take care.